Hello, and welcome back to Source Decoded. This is the first video in a series that I'll be doing about the World Wide Web and the Internet. I'm going to start at kind of a basic level and try to explain how it works. If you're an aspiring web developer, this is probably going to be interesting to you. If you're not, and you're just you like the Internet and just want to know how it works, hopefully this will be interesting to you too. So first, as always, we better start with some definitions. What is the web? The web is really a collection of documents that have been linked together in interesting ways. Like you might have a document here about paleontology, which might link to another document about a dinosaur. A document about one thing, I don't know, a word links to a document about a dictionary. It's just a lot of documents linked together. What's interesting about the web and what makes it really powerful is the fact that these documents are spread out all over the world, and that's why we call it the World Wide Web, WWW. These documents live on different computers. Some of them live on the same computer, of course, but these documents can live on pretty much any computer anywhere in the world. And these computers, well, the documents are linked to other documents on other computers, but these computers are linked to each other so that they can share information. And when you are using the World Wide Web, your computer is connected to this network too. This network is the Internet. There is a difference between the World Wide Web and the Internet. The Internet is computers networked together across the world. The World Wide Web is these documents that are linked to other documents all around the world. Now, in order for these computers to talk to each other to make the World Wide Web work, they need to agree on how to do that. Now, just like a country has a constitution that defines how the country works, the World Wide Web and the Internet have their own rules. These rules are a little different in that there's really not an enforcement authority in most cases that makes sure that you're playing by these rules. That's one of the great things about the Internet is largely it's decentralized, or at least it's designed to be. But if you want to play on the Internet, you have to abide by these rules. These rules are sometimes called standards by computer nerds, and they're defined by a bunch of different organizations like the IETF or the IANA, and I don't know, pick three letters. There's probably an organization with those initials that writes standards. Now, there's a group of standards that explains how computers on the Internet should talk to each other. This is defined in a lot of different documents, but we often just call it TCPIP. This stands for Transfer Control Protocol, Internet Protocol. These are defined they're called RFC documents. These were defined in, I think, 1981 in RFCs 971 and 973. It's not helpful at all for you to know that, but now you can say that you know. Okay, so a bunch of computers networked together on a TCP/IP network find each other by way of addresses. It's like telephone numbers that the computers can use. This computer will get on the network and say, I'm looking for computer number whatever, and send some information out onto the network. And this computer will say, oh, that's my address, that's me. So I will respond to that request. And in this way, these computers can exchange data. Every computer on an IP network has an IP address. Unless you downloaded this video beforehand and are watching it cached offline, your computer has an IP address right now, and it will tell you what that address is. The different operating systems do this a little bit differently, but I'll just go to my Mac here and open the system preferences. And in the network tab, or network preference, I guess, I can see right here that my address is 192.168.2.105. And there's a reason it's organized this way with all the dots, and we're not going to get into that because it's not very useful to you. Now, knowing how this works, we can play around with it a little bit. So I'm going to open a command line here. Most computers come with a tool called ping that you can get to on the command line. If you're on a Windows machine, press and hold the Windows key and then press the R key to open a run prompt, and then type CMD and hit enter, and that'll give you your Windows command prompt. And you can follow along from here if you do that. So here I am in my command prompt. I'm going to type ping, and then look at what my address was. 192.168.2.105. Now if I say ping 192.168.2.105, my computer is going to try and talk to itself. So I'll hit enter here. And you can see it is able to talk to itself. How very clever of it. All of the devices on my network have an IP address though. This is a pretty safe bet to do. Type in your IP address, 168.2, except instead of the last number, put in a 1. And in most cases, this is going to tell your computer to go ping or say hello, essentially, to your network's router. So we'll try that. Oh, I have to ping. Ping 192.168.2.1. And look, my router has responded. All ping does is sends a message out to the computer, to the other computer. It says, hey, are you there? And the other computer messages back. It's like sonar. So what happens if we ping something that is not on the network? Ping 192.168.2. I'm pretty sure I don't have an 89 on my network. Oh, yep. It didn't work. Control C to break that. Now this is just something I did on my own little home network, but a lot of the same things are in play out on the whole internet, just kind of on a different scale. So to talk to another computer, exchange data, whether it's to look up a web page or anything like that, computers use this TCPIP network to communicate. Computers love numbers, and so all of these computers have a numerical address, but we as humans, we don't do so well with numbers, especially remembering them. So it's really awkward for us to know what Google's IP address is. We are clever, and so we came up with a way to get around that. We invented a thing called DNS, which stands for the Domain Name Service, or a Domain Name System. And what the DNS does is gives us a directory to match names that we humans can remember with numbers that the computers actually need to talk to each other. So when I want to visit google.com, for example, the first thing my computer needs to do is find Google's address. So it makes a request off to a DNS server with the thing that I'm looking for, and the DNS server hands back a numeric address. And with that address, my computer can then go contact the google.com servers and ask for something. Now, you can actually see how this works. If you're on a Macintosh or a Linux machine, I checked and Windows doesn't have this tool built in, but there's a tool called dig that lets you do this request. So I'll jump back over on my computer now, and I'm just going to type dig google.com, and I'm going to get some information back. There's a lot of different kinds of addresses that you can attach to a domain name, but this is the one I'm interested in right here in this answer section. Google.com has an A record of 172.217.2.14. Let's try a couple others. Dig youtube.com. Here is YouTube's IP address. Let's dig yahoo.com. Now in this one I got back a whole bunch of A records. And I can make a request against any one of these, and I'm going to land on a Yahoo server. So that's how DNS works. Now, because of the magic of DNS, my computer is able to find Google's computer on the internet. And the next thing it's going to do is make a request for a specific resource, a specific document. We can actually look inside how this thing works, and we will. But first, we need to touch on one more aspect of TCPIP, and that's called ports. Now, when I talk about addresses, you might think of a street, and there's houses on the sides of the street, and each house on the street has an address. 4, 5, 6. That's close, but it's actually a little more involved than that. Instead of every address belonging to a single house, an IP address is more like an apartment building. This is an apartment building. Trust me, it is. And this apartment building has a lot of doors on it, and it's got some floors. This one's 3 stories. And now this whole apartment building has an address. We'll call this, has an address of 3. But there's lots of different units inside this apartment building. These units are like ports to an IP address. So say I have an IP address of 192.168.2.11. That gets me to the computer. But a computer can actually have a lot of different programs on it that are listening for a connection. Those programs are called servers. Now, you may have thought of server as referring to a computer box that is in a building somewhere, on a rack in a server farm. And that's not inaccurate, but oftentimes when we say server, we actually mean a program that's running on a server. So the IP address can get us to the computer box, but we need a port to know which program on that computer box we want to talk to. On the internet, the standards have decided that the default port is 80. For non-encrypted web traffic, web servers listen on port 80. Okay, so let's run through this process one more time. Me, on my computer, I want to go to google.com and search for something. The first thing my computer does is go to a DNS server and look up what this address means. Then it's going to get back a number. Now I'm going to use that number to find the Google server out on the internet. And then I'm going to make a connection to that address specifically to port 80. So why don't we try that out? Now on my computer, I've installed a program called Telnet. It's actually a really old program, but it's not installed standard on most machines anymore. Telnet really doesn't do much except give us a really low-level connection between 2 computers. Basically, I will be able to type text into my computer, and Telnet will just send that text right as it is across the internet to another computer. So, first off, let's look up what Google's address is. Dig google.com. Google's address is 172.217.214. And you might have noticed that we get different addresses sometimes for the same query. That's because Google has a lot of different servers listening for traffic. Okay, so we got our address. Now I'm going to say telnet to that address on port 80. Now I am connected to a Google web server somewhere. And Now I need to ask it for information. We'll go into this part a little more deeply later, but I'm going to say get / HTTP 1.1, and then Google is going to spit back text. This is basically what your web browser does whenever you visit a website. It looks up an address, makes a connection to that address, usually on port 80, or if it's an encrypted website, which most of them are now, it's going to be on port 443, but that's a little harder for me to demonstrate here. And then it asks for / means I want your default page. HTTP 1.1 is the protocol. It says I'm talking to you in this language. And then this is the response that Google sends back. Google is talking to us in HTTP 1.1. It says 200 is a status code. It means everything went okay. And then I get a bunch of headers. This is stuff that your browser does not typically display to you. And then this is a web page. It's all in HTML and JavaScript, and it's all been compressed to take up less space on the internet. But there it is. That is what your browser does. And in pretty basic terms, that is how the internet works. It's really not that magic. Most of the information going back and forth is going back and forth in plain text, unless it's encrypted, which many things are. That's basically all there is to it. Now, I mentioned that one computer could have multiple servers running on it. I want to touch on one more thing here, and that is the fact that one server can actually have multiple websites running on this. Now, this doesn't really happen with Google.com. So Google.com is such a big website with so much traffic that in order to serve it all, they have to use lots and lots of servers. They have literally thousands of web servers spread out all over the world in different places on the internet. How are we going to know these are servers? I'll put a light on them. There. That's a server. Lots of servers spread out all over the world serving up traffic for Google.com. Now, for many websites, like if my website, I don't get very much traffic, and it's not economical for me to have a computer somewhere dedicated to just serving up my website because I'm not near popular enough to generate that much traffic. Maybe someday, but not yet. So something that people do is called shared hosting, where there's one computer, but it has lots and lots of websites on it. In this case, if you were to make a DNS request, let's call this site A, B, C, D, E, F. If I made a DNS request for site A, or B, or C, I'd get back the same IP address for all of these sites because they're all running on the same server. So when a computer makes a request to this server, how does the server know which site to send back? Now, I found an example of a site that is running on a shared server. So let's look at that real quick. One of the standards that was written to set up the whole internet set aside a couple of domains for special purposes. Example.com, .org, and .net are special domains that nobody can register, but you can go there, and there's actually a website there, and we're using this one because it's not secured. So let's go through that process again. I want to dig example.com. Here is an address. Now, I could actually cheat and just say telnet example.com, port 80, and it will do that step for me. Let's go ahead and do that. Now I'm hooked up to this server at that address. And I'm going to do what I did last time, get your default page using HTTP version 1.1. And it has responded, but it's responded badly. It didn't give me a 200 OK, it gave me a 400 bad request. Basically because it doesn't know which site I want to talk to. So let's try that again. Telnetexample.com 80 get / HTTP version 1.1. Now I'm going to say host example.com. One more enter, and look, I got back the web page for example domain. So there's an example of a virtual host. Chances are your first website will be on a shared host somewhere, and you'll share space with a lot of other websites until you get big enough that you need a server all to yourself, or maybe a few hundred if you get really lucky. So that's pretty much how the internet works on a pretty high level. There's a lot more on the internet than just web servers. Any device from your Alexa or Google Home to increasingly light bulbs and other smart devices, these are all on the internet, but not all of them are related to the World Wide Web. In the next video, I'm going to cover some basics of the World Wide Web and how those documents interrelate and why that's really cool. And from there, we'll go deeper and deeper into the workings of the World Wide Web for as long as there's interest, and I have interesting things to talk about. So thanks for watching. You will see me in the next video. Bye.